I want to show you how to divide polynomials using a method called synthetic division. Before I get into synthetic division, as a refresher for how long division works, with x squared plus 3x minus 10 being divided by x minus 2, we are trying to see how many times does x minus 2 go into x squared plus 3x minus 10. To do that, we're going to key off of this x that's out in front, and we ask ourselves, what do I have to multiply that x by to turn it into x squared? Well, I'd have to multiply x by x to make x squared. So I will, but I'll multiply the entire expression by that x. And we're left with x squared minus 2x. Go back and subtract all of that. X squared minus x squared is 0. 3x minus 2x, 3x minus negative 2x is the same as adding that 2x. Then we end up with 5x. And we bring down this negative 10 and do the whole process again. Going back to that x, what do I got to multiply that x by to turn it into 5x? Of course, we multiply it by 5. Go back and multiply the entire expression by 5x minus 10, and subtract. 5x minus 5x is 0. Negative 10 minus negative 10 is 0 as well. So there's no remainder, and this division yields a result of x plus 5. That process is not too terrible on an example like this because the polynomial is just quadratic, and the result is nice. There's no remainder. The long division wasn't horribly long, but it is kind of long. But now, how do we do that division using the process of synthetic division? Well, first of all, we have to set up our process, and we do that. It looks a little strange. It looks like this. First of all, in this little box I've made off to the left, we're going to look at our x minus 2, what we're going to divide by. The number that goes in that box is going to come from x minus 2, but it's not going to be negative 2, and it's not going to be x minus 2. What it's going to be is the value of x that makes x minus 2 equal to 0, and that is a positive 2. After that box comes all of our coefficients of our polynomial, the x squared plus 3x minus 10. So there's 1x squared, 3 x's, and then we have negative 10 as our constant term. Notice I've left one line of space for work before this horizontal line. And then there's this little notch in between the 3 and the negative 10. Now we're ready to actually do the synthetic division. How synthetic division works is we're going to bring down this 1 and then multiply and add, multiply and add, multiply and add. What I'm multiplying by every single time is this 2. 1 times 2 is 2. Then add. 3 minus 2, that makes 5. Now repeat the process. Multiply and add. 5 times that 2 again is 10. And when I add those two together, we're left with 0. Looking at everything that's in my synthetic division, I notice a few things. Like the 5 is this 5. The 0 down here. There's my 10, but it says minus 10. But we're subtracting minus 10 for the positive 10. And we can see kind of working backwards. Here's my 5. Here's that 2. And here's the 1 that's out in front. So really, synthetic division is just a way to condense the process of long division. Looking overall, we see that long division, this example, took 1, 2, 3, 4, 5, 6 lines in our notebook. Synthetic division will always take 3. Long division, if the polynomial is bigger, it's going to take even more steps. But lastly, we do need to get our answer out of our work. And how this is going to work is the 0 that's sitting in this little notch, this ends up being our remainder. And then working to the left, we have our x to the 0 term and our x to the first term. If there were more terms, then this would just go x squared and x to the third and so on. But there is none of that, so our answer is sitting right here as being x plus 5. So let's try one that's a little bit bigger. When I have 2x cubed minus 13x squared plus 26x minus 24 being divided by x minus 4, setting up synthetic division, in the box is the thing that's going to make this equal to 0, and that is the 4. To the right of that comes all of our coefficients of the polynomial. It's 2x cubed minus 13x squared plus 26x minus 24. Leave a space for some work and put our notch in between the last two numbers. Now we're ready to begin the synthetic division. Bring down the 2, multiply and add, multiply and add. So we'll always multiply by this 4. 2 times 4 is 8. Then add. That makes negative 5. Times 4 is negative 20. And add. 4 times 6 is 24. And add. 0. Now we have all of the terms of our answer. The 0 is the remainder. And then we have x to the 0, x to the first, and x to the second. So this division will yield an answer of 2x squared minus 5x plus 6 with no remainder. And there we are. There are a couple caveats to synthetic division. First of all, you always got to watch out for missing terms. In this example, when I have 3x to the fourth minus 5x cubed plus 2x minus 7, notice that in between here, I would normally have an x squared term. That term is missing. But we'll just kind of think about it as being there, just that there are none of them. So we could rewrite the problem as being 3x to the fourth minus 5x to the third plus 0x squared plus 2x minus 7 being divided by x plus 1. We could go and set up our synthetic division now. In the box, I'm going to go back to what we're dividing by, and by now you probably see that we just take the opposite of what's in there. Instead of it being plus 1, I'm going to use minus 1. Then go back to my larger polynomial, take all the coefficients, 3 minus 5, and for that missing term I'm using a 0, and 2x minus 7. Leave a space for work, put the notch in between the last two, and get ready to go. Bring down to 3. Multiply and add. Multiply by negative 1, we have negative 3. Add, leaves me with negative 8. Times negative 1 is positive 8. Adding them together gives me 8. Times negative 1 is negative 8. And add is negative 6. Times negative 1 is positive 6. And adding leaves me with negative 1. So, my answer from this division, this time I do have a remainder. Then x to the 0, x to the first, x to the second, and x to the third. So the answer will be 3x to the third minus 8x squared plus 8x minus 6. And how are we going to deal with that remainder? Well, similar to how you deal with a remainder in a long division problem of numbers, is we would take that remainder and put it over our divisor. And that's what we're going to do here as well. I'm going to add the remainder as a fraction, 1 over x plus 1. The same x plus 1 that we're dividing by here. And that will be our solution. One last note about synthetic division is that it works best when we're dividing by x plus a. Anything in that form where it's x plus or minus a number. Not x squared plus or minus something or 2x plus or minus something. It'll still work. It's just that we have to take that into account. To illustrate what I'm talking about, I'm going to take this 2x cubed plus x squared minus 6x minus 3 divided by 2x plus 1 and write that as a fraction. So divided by 2x plus 1. I want to use synthetic division, so I need to divide by something that says x plus a. So that 2x cubed plus x squared minus 6x minus 3. Instead of dividing by 2x plus 1, I'm going to factor out the 2. I'm going to divide by 2 times x plus 1/2. Right? Now I can do synthetic division, and I'll use my x plus 1/2 to help me through it. Setting it up, I need my box. Inside that box will come from the x plus 1/2. I'll use the opposite there, that negative 1/2. And after that comes all the coefficients of my numerator, that 2 plus 1 x squared minus 6x minus 3. Leave some space, put a notch. Then we can go through the whole process. Bring down the 2. And we're going to multiply and add, multiply and add. So always multiply by this negative 1/2. 2 times negative 1/2 is negative 1. When I add those together, I'm left with 0. Half of 0 is 0. Adding to negative 6 leaves me with negative 6. Negative 6 times negative 1/2 is positive 3. And when I add, I'm left with 0, which is pretty nice. Right now, it looks like our division has turned into 2x squared plus 0x minus 6. But we're not finished. I still haven't taken care of the 2. So I still have a fraction that needs to be divided by 2. In this case, that's not too bad. I'll split it up into 2x squared over 2 minus 6 over 2. Leaves me with x squared minus 3. So you can actually divide by something that doesn't look like x plus a, but you need to break it into those linear factors first, and then take care of everything else afterwards. If you want to divide by that entire 2x plus 1 all at one time, you should resort to long division.